Wow, this is a long one. There's E parts. Melissa, pick an even. Oh, you want 48? Fine. Let's go and find part A, when we find the vertical and horizontal asymptotes. To find the horizontal asymptotes, we need to run some limits. So, if I'm looking at this one, that first one, that yellow one, as x goes to positive infinity, that's e to the x over e to the x over 1 over e to the x minus e to the x over e to the x. Yeah, and then I'm running that limit. And when I do, I'm going to get 1 over 0 minus 1, which is that minus 1. Now what? The limit, as x goes to minus infinity, this guy, he goes to 0. And that's really the only one that matters. Well, this one goes to 0 also. And wait, there's more. It's left over 1. So I have 0 over 1, which is 0. So that's my horizontal asymptotes. Now, to find the vertical ones, we need to worry about where the denominator is equal to 0. Because you can never divide by 0, you can never divide by 0, you can never divide by 0. So we set the denominator equal to 0, bam, use logarithms O, and the natural log of 1 is 0. So, we have a vertical asymptote at 0. Now we want to find part B, where it's increasing and decreasing. We do that by taking the derivative. That's a quotient, so I use the quotient rule. It's low, d high, minus high, d low, all over low, low. And then we go, and we factor out an e to the x, this one. It's in both of those, so we take it out. And then left over, we have minus 1 minus e to the x, and minus make plus e to the x. Those guys, they reduce. And we deduce that we're left with our derivative. So we set our derivative equal to 0. And we solve. Well, the numerator is never going to be equal to 0 because it's e to the x. So we only worried about our critical values when the derivative is undefined. So we set the denominator equal to 0, and you could even say that this is squared if you want, but then you take the square root of 0 and you end up with just 1 minus e to the x is equal to 0, and again we use logarithms, and we find that our critical value is when x is equal to 0, so we test this guy on a number line where 0 is our critical value. And that numerator is never 0. It's always positive because it's e to the x, and e to the x looks like, that could have been nicer. And then in the denominator, that one is negative, but that square right there is always going to make it positive. So when we're testing our interval, we find that we're increasing almost everywhere except for 0. Because, yeah, that's a vertical asymptote. Local mins and maxes. Since our first derivative looked like this, boom, boom, we never switch signs, so we're not going to have any local mins or maxes. Concavity. That means we need the second derivative. We're also trying to find the inflection points. So, that's our first derivative. Boom, it's low, d high, minus high, d low. Now, when we're taking the derivative of the denominator, we're going to have to use the chain rule. Take that, rewind it back, evaluate it at the inside, and multiply it by the derivative of the inside. But then what? Now we factor. Fancy factor. We have 2 here, and we have 1 there, so we take one of those out. And then we have 1 e to the x here, and another e to the x there, so we take an e to the x out. And when we do that, we're left with one of these on the inside, that's this, and 2, and then plus, or minus and minus make plus, so it's plus 2 e to the x is left. Okay, so then when we clean that up, boom, we get our second derivative to be this guy, yowzers. Now again, this numerator is never equal to 0. Why? E to the x is not 0, so then when we add 1 to it, it's not 0. And that denominator does equal to 0 because 1 minus e to the x equals 0 when x is 0. So we're testing this muffin, that one, boom. And we find that our derivative is positive on the left side of 0, and it's negative on the right side of 0. Why? Because this denominator down here is the only one we're concerned about. And when when x is big, e to the x is bigger than 1, making that denominator negative. And in summary, our concavity, we're concave up when the derivative is positive, we're concave down when the derivative is negative. Let's go and get the full picture. I've created a summary here. Our limits, boom, that one, yeah. As it goes to infinity, it's going to minus 1. As it goes to minus infinity, the graph is going to 0. So, it's increasing on this interval, so that means it's going up, and we have a vertical asymptote at x is equal to 0. That's this business. Yeah, so it's going up. It's got no max or min, it's infinity. It's concave up here. It's concave down there. Now remember, you can pause this video at any point if you wanted to check out those derivatives.